And that's important. It's good to know what you shouldn't do in addition to what you should do. So first off, if anybody's ever heard of a software development lifecycle, many organizations have them, and they basically just describe how do you go from nothing to a feature in a product. It's really straightforward, and the smaller the organization, the smaller the chart. The bigger the organization, the bigger the chart. And so here's just an example that includes things like design and architecture and QA. We do QA and test, right? And then you deploy and maintain. This is very standard. They all look different, but this is just an example that I made in Microsoft Paint of what it could look like. I love Microsoft Paint, by the way. Those like low-tech tools are so great. Anyway, this is what we often end up seeing, though, in the AI world. And it's not necessarily like intentionally like we're trying to break everything, but very often we're rushed, we have new features, we have deadlines, there's money involved, and everybody wants to really do things fast. We want to do it fast, have minimum viable product, and sometimes we go a little too fast. And this happens. And the VP or manager says, do it, and you say, OK, you said so, and then you do it, and then things happen. And by things, I mean bad things. And those are the things we're trying to avoid today. And the reality, the biggest challenge of AI is that underneath all AI is data. No matter what you're doing in artificial intelligence, machine learning, analytics, dashboarding, all the stuff that we do with data, underlying it is that data. And the biggest challenge is that data gets bigger and bigger and bigger, and we do more and more and more with it before it hits your desk. And so if you're at a teeny company, teeny organization, you're just starting out, your data may just sit here in a database, and life is simple, or over here in some files, and it's really simple. But then as time goes on, we transform it, we copy it, we move it. We need high availability, disaster recovery. We want it all over the place. And after many runs through the mill, suddenly your data has moved a lot. It's changed a lot. And every time that happens, there's a risk for things to go wrong. Not because we're bad at development, but just bugs are natural. Anybody here ever worked on a major release for a product that had no bugs? None? Zero? I've asked that question at jobs before. When you ask that question, people get really mad at you because they think you're insulting them. But it's just we're human. We're human. And so the downside is that if you have any bad data, it goes downstream. Things just go downstream, right? And if you have good data, but you then make a mistake along the way, well, that bad data also goes downstream. And as a result, you get to your AI, you give the data to your AI, it does things for you, and you're happy. But if there was any bad data along the way, it's going to give that back to you. And it's not going to tell you that it's bad data. It's going to be very authoritative. That's what AI does, right? It lets give you answers, not choices, answers very often. And so we have to be careful. This is really our big challenge we're tackling today. And so our first section of this is going to be how do we prevent bad data? And I'm just curious, how many people here have managed data before or worked with it? Lots of hands, probably everybody, right? It's hard to avoid it. How many people have worked on software that ran into bad data that made your lives miserable? I see hands. When I say good, I don't mean it in a bad way, but good. We've experienced this. We understand what this is all about. If you haven't experienced this, either you're very lucky or you have bad data and don't know it. So I'm going to think of data as like a digestive process. You kind of like eat up here, and then it works its way through your body. And so at the beginning of this journey, your data is transactional data. That is order processing, accounts, managing the things that you do in applications and games and edge devices and things like that, right? Like I have a watch here. It collects tons of data all about me. And then it works its way to my phone, to like the cloud, back with some more information. And this is the beginning, though. It pulled the data in, and that's the beginning. The simplest way to validate data in the beginning of its journey is constraints and keys and things like that that manage data up front. If you're not in a transactional database, that's OK. You can still validate your data. But as people enter data, you can validate it in the application. Like, I'm supposed to enter a name. Can it have special characters? If the answer is no, you should make sure I don't do that. And then validate it wherever your data is ultimately going to, whether it's databases, filed, structured, unstructured, whatever. Have validation there. If it's very important, like you work for a bank or something, you'll probably have things like constraints to enforce it, to say that if bad data comes in, you're going to kick it back and throw an error message. That's how important it is. And I've worked with order processing data and money. And I'll tell you, when you work with money, bad data is a really bad thing. When you work with security, bad data has consequences. Medical records, bad data has huge consequences. And so sometimes we work in products where the consequences aren't as apparent. but in some it's immediate, and that's usually transactional data. If you have bad data here, it will last forever. It won't go away, it won't get better, it won't get healed, it won't cancel itself out, it will stick around forever. You don't want that. And so these are all the things I kind of just mentioned. You can do many of these. My general advice is do more than one. Validation and having good data is very much like security. It's like an onion. You want layers of it. Security is not a wall. I don't build a wall and hide behind it while the hackers and people trying to trick my guys into responding to emails all get tricked. You want layers. And so to keep good data, you want layers. You want validation in your transactional data, validation in your ETL processes, your final data. Yes, a question?
What's OLTP?
Great question. I use acronyms, and I didn't define them, which I shouldn't do. Online transactional processing, it just means transactional data processing. Otherwise, your nitty-gritty data that's being inserted, deleted, updated, constantly being worked with as part of a software application. Online transactional processing. The acronym isn't that important, honestly. What it is very important, though. And that's really your application data is what it's describing. So whenever you open an app, whenever you take money out of the bank, whenever you really do anything that involves software, it's probably transactional data of some sort. It may be eventually consistent, non-relational, it can be all kinds of things, but ultimately you're making changes, and those changes matter, right? And so having layers of validation and security and checking constraints and so on will make your life better. And then eventually data goes from there elsewhere. In the beginning it's just you have a database or a data store and everything's there and everything's great, but eventually someone says we're getting bigger, we want to understand our data better, we want to copy it places, we want to do analytics, dashboards, machine learning, AI, and that's what we're all talking about today, right? We want ethical AI, responsible AI. But your data is the source of that, and without good data, you can't accomplish that effectively. And so the question is, as you move data out of because if you do all of your analytics and your transactional data and you shove everything in one place, it's going to perform poorly. So very often you're going to take and copy your data somewhere else through whatever processes you use, and then run all the cool machine learning, AI, analytics, and so on and so forth. But as you copy data, as you transform it, as you move it, as you may build data warehouses, data lakes, lake houses, things like that, you can get all fancy. You can shuttle it off to the cloud, to third-party services. Did you do it correctly? And the checks are easy. Just check for simple things. Row counts, min and max values on columns. Is there enough data? Are we missing data? No one ever checks for missing data. But if it's missing, that's bad, right? If you expect data from 10 databases or 50 servers or 100 file stores and you only get it from 20, what does that mean? Is something broken? Should we let somebody know their thing is broken? So check for good data, check for bad data, check common data scenarios. You can really capture a lot with super, super simple stuff like that, just row counts and distinct values, things like that. Is the value valid? I've seen systems that manage money before. People put transactions in, and sometimes people fat finger numbers and put in big numbers, but you may not want somebody putting in that they just closed a sale for $1 trillion, because it's probably not true. I've seen that happen, by the way, in an actual production environment. People flipped out. It was great. So much fun, 'cause it wasn't my problem. But always validate before you begin training your models, before you begin bringing your data to AI, before you do any of that stuff. Validate your data, and you don't have to be perfect. No one's perfect. But you want it to be as good as possible. You want to avoid the knuckleheaded stuff. You want to avoid 50% of your data being bad or missing 25%. If a few rows are bad, we'll deal with it. If a lot of it's bad, you're not going to go anywhere good. And then something we also neglect very often is what happens when we make changes? Who here makes changes to software through software releases and code changes? Who expects to do that in the future? I see a lot of hands tentatively wobbling their way up. When you make software changes to your application, that will change how data is created, and that may change how it gets stored, and that may change how it gets used for further processes down the line. And so whenever you release software changes, make sure the data afterwards is still correct. If you add new data elements, new columns, new files, new data sources, make sure they're valid, they're correct, test them. Test what's inside of them. In QA, we very often create crazy data, right? We just have fun. We don't use real names. We use fake names, use fake stuff. But if it's too fake, you may not really know what's real or not real. it's very important to know that whenever you make changes to applications anywhere, that we're also checking the data as well, not just the app. Does it work? It works, it compiled, yay. No. Is it actually valid? Is everything correct? Is it working right? That's important. If you don't have QA, then the things that may have worked perfectly before may no longer be so perfect. This is like basic stuff here in the world of data. I see terrible things happen all the time. General database design guidance is you want to name your columns with names that make sense, that describe what the thing is. And if you have to pick a data type for something, choose a natural data type. Anybody here ever seen dates stored as strings, or like a yes or no question stored as an integer, things like that? Startled hands. That's bad, because I look at that data element and I don't really know what it is. You know, if I saw a column that was called isDeleted, but it's an integer, well, I thought I knew what it was. Is it a 0 or a 1? But now I'm not really so sure. Why do some values have a 3 in them? And that's bad data potentially. Or mystery data that I don't understand, that I have to go talk to somebody for a secret decoder ring or something. I don't know. But you want to name things well, type them well, and also check, should data be excluded from any analysis you're going to do? For example, that column named isDeleted. If some data element has isDeleted and it's 1, should I include that in my AI training? Should I exclude it? Is it important? I don't know. Is when it was deleted important? I don't know. These are organizational, business questions, and to really draw any true insight out of data, you've got to know that. And there's like a thing on the floor here I'm going to trip on eventually. When I do, you can all laugh at me loudly. But I look at these things and I just ask questions like, well, is the entry time a time or a date? You know, if it's named invoice, does that mean the invoice amount? Does an invoice exist? What does it mean? And the reason why this is important more than ever isn't just for us, but also because your algorithms that you're going to throw all this data into are going to make assumptions based on potentially this metadata. And if it's wrong, if the column names are misleading, if the data types are misleading, it may also make bad decisions. You know, if I can look at your data and make a bad decision, the computer very well may too. So just keep in mind that how you structure and organize your data, how you name things, how you type it, will impact how it gets consumed by AI. And if it's not well done here, it's going to make mistakes. And you won't like those mistakes. One additional note on data. In the world of AI, there's really 2 primary kinds of data. There's training data. That's the data I throw at it to say, I want you to learn how to behave. Training data is all about behavior. How do I want a model to behave and react and do things? And then there is RAG data, which is retrieval augmented generation. And retrieval augmented generation, I'll say it nice and slow since you're writing it down. But basically, that's just the bring your own data. So I've trained an algorithm. I have ChatGPT 4.0. It's doing what I want it to do. It behaves nicely. But it has the data set of the internet, which I don't really want. Who relies on the data set of the internet for much? I mean, we do, but I wouldn't like trust that with my life. You know, I wouldn't go to Stack Overflow with a random question that's very complicated. It's, you know, I wouldn't bet money on that. So then you bring your own data and say, okay, I work with an airline. I'm going to bring all my airline data and put that into my algorithm. So now I've trained it on this data set, and now I'm going to bring my own data, and then it's going to behave the way I want and return valid results. It's important to know these are 2 separate sources of data. You cannot use the same data for both. You can try. You're going to have weird behavior, but you really want to train on one data set and then use a different set of data as the actual data you're going to provide answers with. That's really important. So bad training data means weird behavior. Bad bring your own data means weird responses, the wrong ones, wrong data, wrong information. So at this point, that is all about data quality. Why does it matter? Why do we care? And how do we kind of prevent it in our source data systems? Now, I'm going to talk about, for the rest of the time here, how do we cheat bad data with AI? This is the fun part, right? This is all the terrible things that I've personally seen people do. And I've been updating this presentation like every month with the new bad things I see people do. Ooh, a new feature that came out in this product. I'm going to use it and abuse it and break everything. Great. Awesome. Wonderful. And by the way, if anybody has questions, we can chat afterwards, only because there's not a lot of time. And so if you have questions that aren't like complicated, we'll probably save them for the end or just kind of afterwards when we're letting the next speaker on. So the first thing we do when we're kind of putting together an AI algorithm is if you're trying to work with a chatbot or anything like that, you need a prompt. The prompt tells it how to behave. What is it? What is its purpose? You're giving purpose here to the thing you're building. What is that purpose? And the prompt does that. And what often will happen is people will do all this work. They'll train an algorithm. They'll put some data in there. It's behaving correctly. And then at some point, it gives a bad response. And you're like, wait a second. That economy seat on the flight should not be $3,000. It should be $300. Where'd you get that from? And that probably is bad data. Probably. It could be something else, but it's probably bad data. So what they'll do sometimes, because they're so close to done, is they'll adjust their prompt a bit to try to add in detail. Like, oh, and by the way, if it's over this amount, do this. If it's less this amount, do this. Economy means this. I am here to provide you with information about flights for economy, which is this, and for business, which is, and you go on and on and on, your prompt gets really big. You can't cheat with prompt engineering. I've seen people do it. Your prompts get ridiculous. Everyone laughs at them, but you're in a rush. We have things to do. The idea of going back and retraining and going through all of our data sounds daunting. And so we skip around the problem. And the reality is, when you tell the prompt something very specific, it's going to believe that specific thing is part of how it's built. It's not a detail. It's not a nuance. It's part of its personality. It's like saying, Ed, I want you to always behave this way. But by the way, do this and this and this for the situation. But I'm going to think, oh, that's really important. That's an important part of my value system. And I'm going to behave based on that too, equally. You can try to weight things, but again, the more complicated your prompt gets, just the harder it gets to control it. It doesn't need to be short, but you don't want it to be overly nuanced, because the nuance will get lost, and it'll be very hard. You'll move the painting in this way, and it'll begin behaving this way. You'll push it back this way. You'll move it over here. The downside is going to be that you're going to prompt your way into oblivion, and your prompt's going to be very complicated. So when you get a bad response, the first thing you have to really do is define where is it coming from. What is the actual source of a bad response? And it actually isn't as hard to find as you think it is. You can go back to your data source and quickly figure out, is that seat price wrong on the flight? And no, is it wrong? If it's not that, okay, where else is it coming from? And work your way through. But the moment you begin mucking with your prompts to get rid of bad data, you're going to probably create more bad responses, and it'll get harder to diagnose the problem. So just don't try to prompt your way out of heck. It's not going to work. You're only going to dig yourself into a bigger hole and make your life difficult. This is our bring your own data, retrieval augmented generation. This is the part where I say I'm going to take my data set, feed it into the algorithm so it can answer questions the way I want to, but with my data. This is how we go from our data set being like the internet or fun data or QA data to using a real data set that I care about. That's going to be viewed by customers or by people or by anybody important who's going to need to know information. Don't train your model on the same data that you bring for this purpose. You can, but it's not going to give you what you want back. What you really want to do is train on one data set for behavior and then bring your own data to ensure that you're getting the correct results. You can't fix bad training by bringing your own data. You can't add data to your data set to try to undo bad training. You can't add data to your data set or remove it to fix any mistakes made previously. And if you have bad data on your original data set, then trying to fix it here is going to be messy. Ultimately, the more you try to muck with it after the fact, the harder it gets. But if you're bringing bad data, and your bad data is right here, it's actually pretty easy to fix. You brought a data set, you brought it in, it has a mistake in it. All you have to do is remove it, fix the mistake, and do it again. Retraining this data is not hard. Your algorithm's trained, it's good to go. You're just handing it a pile of data, and it's not hard to stop and say, let's give it an updated set of data, which you're going to do anyway, right? Like we're going to have airline prices tomorrow, right? We're going to have new flights tomorrow. And so we're going to be updating data all the time. That's normal. So fixing this is probably one of the easiest things you can do, and hacking your way around it is one of the worst things we can do because this isn't hard to fix. Semantic search is really focused on how do we take speech and words and written documents, split them up, and make sense out of them. We're associating words with other words. Underlying this is a lot of math. I'm going to have a simplified example in a moment what that math looks like. There's a lot of math under this. And when you bring bad data into this, you're taking bad data and putting it into a complicated set of math that's going to basically drive vectorization, which is going to tell us how much do things relate to each other. And so once you're there and getting bad results, going backwards is hard. And so you can't really fix things after the fact here. You have to go back to your original data, figure out what the problem was, and fix it. And the good news is, I see a dance back there, cool, is that usually there's a problem here. It may sound complicated, but your original data will make sense. Like if I have a result here, and like, you know, let's say this is kind of how it looks at a very, very simplified level. You just take different words, different phrases, different things, and associate them with numbers. You know, in an example like this, one means they're perfectly associated. Like dog and canine, cat and feline. Those are things that are related. And then negative means unrelated, opposites, different. And when you have lots of this, you can formulate ideas about how things relate. And that way, if I ask a question about something that you don't specifically know, you can check and figure it out and understand it. And if for some reason I had an example of some output that showed dog is feline, you can go back to your original data and figure out, okay, let me look at anything related to dogs, canines, things like that, what happened, and then figure out the mistake. But you can't fix anything here after the fact easily. It's very, very hard because you've performed complex math, and undoing that after the fact is just as complex. So, and reality is like this, but way bigger, way bigger. So this is cool stuff, by the way. It's really, really cool to learn about. But fixing it after the fact is very hard, but going back makes it easier. I'm curious, because we're doing great on time, does anybody have any questions so far on anything I've talked about? Data quality, naughty things you shouldn't do? Yes?
How can you, like, I guess a lot of the LLM type data comes from the internet. So, like, how can you make sure, like, the data that you are, like, cleaning is, well, I guess, how can you tell what is valid and what's not?
With a large data set that you're not responsible for, it's honestly very, very hard. A lot of times what most organizations will do is that internet data is their training data, and then they are responsible for a set of their own data, and they use that. Now, if you're using the internet as your data source, you actually want to keep using that data as your data source, I would limit it and give it some guardrails. You don't want the entire internet. What you really want is data related to certain things. You may want data related to everything, but most applications don't want everything. You may want, like, I'm going to build an app that's going to provide technical solutions for Google professionals. Okay, cool. Then that's a small subset of the internet. And you can take that and use that as the data you bring, train on everything else, and then ensure that whatever you're bringing is correct. It's really just QA at that point. It's quality assurance. It's testing to make sure that your data that you're actually going to use is valid. And so it's a combination of choose a good data set for your application and test it a whole lot. Testing a whole lot is really important. It's boring. Not everyone loves doing it. But if you work in QA or ever have or ever will, it's a really important job. I love the QA people I work with. I tell them all the time how much I love them. I can't do what they do very well, but they're really good at it. And they make my life better. Yes?
How would you test the data? How would QA test it to make sure the data is good?
It's a good question. So at the beginning of the line, when you have an application, you have data being put into tables, you're testing that in an application. But we're here all talking about AI today. And so at this point, when you're down at this point in the line, you've built a semantic search model, and you're going to have text analysis, things like that, speech analysis. The answer is people are going to test the actual AI algorithm and application itself. And so, for example, if you made a chatbot, and we're going to chat with the chatbot, this is definitely going on here because it's going to have to figure out what I'm talking about. If it has a bad response, you bring that back to the developers and say, here are all the weird responses I got. We do this all the time, right? Like how many R's are in strawberry. We all, yes. we see things like that all the time, and we chuckle and laugh. Oh, the AI algorithm is saying funny things again, but it's not really that funny because it's wrong, and that makes me wonder what else is wrong too. So, but that's really how you do it, though. If you have an application, you're building it to use AI, The QA person is simply going to be asking questions over and over, trying to break it, right? It's like the old classic joke that people make. You know, a QA person comes in the bar, they order 1 beer, they order 3 beers, they order pi beers, -1 beers, 99999 beers, right? And that's the joke. You try to break it, because if I can break it, that's bad for more reasons than just this. And I'll get to that in a few moments as to other ways we busted up because of that. So now there's some more detailed things we can do in AI that give us some power. A really fun one is fine-tuning. So all right, we've trained an algorithm. We like how it behaves. We've brought some data. We think the data is good. We're really happy. But every so often, it gives a response that isn't quite right, or just it isn't quite valid for my use case. Like I wanted it to talk about airline prices and seats, but every so often it mentions a bus scenario or something like that. I don't know why. I know that it's in the training data somewhere. It's not in my own data. It's really close. It's so close. The key, and then you fine-tune. So fine-tuning is you take a model that is good. You're happy with it. It's like 99.5% correct. But you want to get it to be more application-specific. Like you want it to really be really hyper-focused on one thing that you do and do well. And that's what fine-tuning is for. And it's a feature available in many AI platforms now. It allows you to say that I've got this thing, it works great, but in certain scenarios I want to adjust it slightly to make it more relevant. And that's OK. It's important to note, though, that making it more relevant is not the same as fixing bad data. If you have underlying bad data somewhere in there, well, not only that you may have more, which is bad, but this won't fix it. This can cover it up a bit or sidestep it, but it won't make it go away. You've still trained or brought bad data. And so you really can't fine-tune yourself out of bad data. Fine-tuning is something you do a little, and it perfects your algorithm. It makes it beautiful. It makes exactly what you want for your particular application you have. If you're doing this over and over, though, if fine-tuning is like a habit, and you're fine-tuning, 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 fine-tuning all day and night, that's bad. That's a sign that you're not that close, and you're not fine-tuning. You're just trying to develop around a problem at the last minute because going back seems hard. Fine-tuning is just that. If you're doing a lot of it, it's not fine-tuning, right? That's like when you go back to somebody and they say, hey, how did I do my homework? And you say, well, it was perfect, except for this and 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 this. You've ever had that before? Where someone's like, you did a wonderful job. Now here are the 40 things to improve on. You're like, why don't we just focus on a few? Because like, that didn't feel good. Yes?
Why do AI engines have hallucinations?
That is a great question.
Repeat the question.
That's a wonderful... The question is, how do AI algorithms get hallucinations? And they can come from many places. The most common places that I've seen are false associations, so like a semantic model where it thinks things are related and they aren't, or bad data. Bad data will create, we call it a hallucination because it's returning things that don't exist. And what really happens is it associates things that are not really associated, it thinks they make sense, returns them, and you get bad results. And that isn't what you want. It makes something up. And the making something up is very often where it says, I see this, and this, and this. I'm going to bring it all together and return a result. Like and in general, the more complex a question is, the more likely it is to hallucinate. In general, AI, even the simpler algorithms, the older ones, are great with generalized, simple, lower-level questions. When you get to more advanced stuff, it gets harder. If I were to ask a very, very simple question about software development, like how does this function work in Python, there's a good chance that any algorithm you ask will give you a good response, probably. If you ask it a complicated, nuanced question, like, I have a parameter sniffing problem in a stored procedure. In the specific case, it's giving me the wrong result. What do you think? That's where it may make things up. Now it's going to grasp at straws. I ask a complicated question. There aren't 1,000 sources. There's 3. And I demo this actually very often. I sometimes will present on very detailed topics, very, very detailed topics. And I'll just go and ask ChatGPT the premise of the presentation. I'll ask the topic, and it's going to make stuff up every time. It's just too detailed. Yes?
How can it tell you the confidence level of the answer? So if it's not 100% sure, it says the confidence of this answer is at 0.85.
That is a great question. And so the question was, why can't I simply have the confidence level alongside the results? And the answer is, most algorithms provide that. And you can look at that and see it, and use that as a way to gauge how good is your response going to be. But if you're building an application that people are going to use in the real world, you can't have a confidence level. It's got to be correct. Like if I'm asking the airline for a price on a seat, it can't say, that seat's going to cost $213, 50% chance. So should I buy that or not, or go to a different airline? And so the challenge is really that when you're testing and QAing and working with data, it's very, very helpful. When you're building a real-world application, you can't really put the confidence level, and this is more of a testing application or a fun application. But for a real-world thing, if you're a bank, a hospital, an airline, a security organization, the government, you can't do that. You can't have a confidence level. It's going to be 100. You've got to basically be 100% or close enough that occasional mistakes are bugs. And occasional bugs are OK. Not the end of the world. One more question. Yes?
So, in cases if you're relying on AI to give you a factual answer, if it's also like supposed to be generative or creative by nature, how can you make sure that if it's giving a fact-oriented answer is like less probabilistic?
That's a good question. So how do you take generative AI, which is more creative, but you want it to give factual answers? How do you make that work in a way that isn't going to make your life miserable? And the answer is really going to be the parameters of what you're doing and how it has output. For example, if you ask me, I'm going to give the human answer here, because the human answer honestly makes a lot of sense to this. Let's say you came to me and asked me, hey, Ed, how would you solve a problem here? I've got to build a data structure to store some data in. What do you think I should do? I probably know the answer to that question. I could probably answer it with a very high level of accuracy, because it's what I do very often as part of a living. Data architect means I'm building these things all the time. So I can give you a really good answer, and I'm confident about it, and I will sound confident about it, which is probably what you want. And on the flip side, let's say you came to me and said, hey, Ed, I'm writing some Ruby on Rails code to do something, and I really like some help with that. I'm going to say, I've done that like twice. I don't really know it that well. So here's what I think, with the caveat that we may have to go do a little more research. And so that caveat is how I gave you a response that showed my confidence level without making me useless. On the flip side, you could simply say, here's the answer, but here's some references to learn more, or here's where to find the answer. And so sometimes you don't have to give an authoritative answer and be right or wrong. You can give people guidance as to what to do and where to go and how to learn. And that is important. Again, if you're a bank or an airline, you can't get that creative. You just can't. You can be creative in how you speak. That's different from how do I give correct responses as well. You know, correct answers and the behavior are different. And so you have that nuance. All right, one more question. Why not?
So I'm curious about the recent scenario where lawyers asked AI, which, generative AI, they asked to write a legal brief, and it made up legal references to cases.
So the question is, what happens when lawyers make up documents using AI and AI BSs, make stuff up along the way?
Like factual, like this reference does not exist. Yeah.
Here's a case of this person versus this person. In 1989, it's very important it didn't even exist. That's a hallucination, and the answer is you've got to check your work. If you're going to have AI do a lot of work for you, generate documents, and I've worked as an editor of articles for like publications, and I see this all the time now. People use AI to do more and more of the work, and when you lean on it too heavily, it makes things up eventually or does things wrong. And the answer is you've got to check your work. If you're relying on AI heavily right now to write documents for you, to generate content for you, you've got to check it. You have to check the work. Somebody's got to proofread it and validate it. I know this isn't fun. You want to trust it, right? But you have to ultimately check the work of it. Read through it. Be your own editor. And if you don't do that, you have to do that anyway, right? If I wrote it by hand, I would check my work. This is like in math class in 7th grade, right? Check your work. Like, it's no different now as adults. It's no different. You've got to always check your work, no matter where content comes from, whether the AI did it, or I did it, or you did it, or a team of people did it. You've got to check it. If nobody's checking it or editing it, it's slop, it's garbage, it may be wrong. And so checking your work is as important than ever. You can't ever just trust it. Even if the confidence level is high, you can't just trust it. I want to move on and kind of finish up. We can make time at the end for questions. So some more newer features I'm going to throw at the end here for fun. One of the biggest challenges that organizations have today is quantity of data. They want to train, 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 and we're running out of data. Like, you think the internet is infinite, there's infinite data, but the reality is we've trained a lot of it already, or it's old, or out of date, or it's garbage, and we need more data. And so many organizations, Google, Microsoft, Amazon, all the big ones, they're training on you right now. When you do a Google search now, it isn't just giving you results. It's training on what you do, on what you put in there, what you click on. It's not just learning better results, it's training. And most apps are doing that now. And they're trying to create new data sets to work with. Synthetic data is when I say, I don't have enough data. Like, I'm doing a study, for example, of public health for the past 5 years. I have all the sample data, but it's not enough. I have like 10,000 data points in 2 states, and it's just not enough. I need more. And so at some point, people may say, all right, I'm going to generate data. It's going to be artificially created to meet my scenarios that I want. It's going to mimic real-world data. It's going to feel like real-world data, but it's not real. It's kind of like QA data. Like, I need to test to see if things are correct or not, so I'll just generate data. People often will create this because they don't have enough data, or they'll create it because their data is secure. There's credit card numbers, social security numbers, things like that, where I can't just throw that around, right? If I can go to ChatGPT and say, hey, what's John Thurman's social security number or something, that's not good. You shouldn't be able to do that. I shouldn't be able to ask for that information and get it back. That's PII, personally identifiable information, and nobody should know that. It gets leaked all the time, by the way. There's been so many security breaches in the past week, by the way. Just don't get me going. Don't get me going. But the key, though, is that if you're going to create data artificially for any reason, you've got to prove that it's as valid as your real data and actually adds diversity to your data. Simply copying your existing data and using more of it won't actually help you. It'll seem like more data, but it won't provide anything new. You know, it's like the classic problem of, back in the 80s, for example, they did a study to see, is red wine healthy? And everybody wanted it to be healthy, right? Is drinking healthy? I would love it if it were healthy, right? Yes! Awesome, I'm being healthy every Friday night, woo! And so there was study after study that said people that drink red wine are healthier than other Americans, and not by a little, by a lot. But guess what they actually saw eventually? The goof was that everybody who drinks red wine at that time, because wine was expensive, had more money. And so what they were really correlating were rich people were healthier than other people, which is a little depressing, right? So red wine wasn't really healthy. It was just the fact that if you had great health care and had a lot of money, you just happened to be healthier because that's how life works in a capitalist country. But the point, though, was that they didn't have data, and they didn't know what to do, and so they just took as much as they could, worked with it, but it wasn't valid. You need a diverse data set. So one of the keys to all analytics is you need diverse data, or you can't create good insights. And you might be able to have synthetic data created to help you, but you've got to prove that any data you add synthetically is providing value and diversity, or else it's not actually helpful. Me giving you the same thing copied 10 times isn't a diverse data set. It's just more of the same. Whew. This is a newer feature being found in more models. This is the scenario of I trained a model, I've tweaked it, I've fine-tuned it, it's perfect, I brought my own data, the data seems awesome. And then at the end, every so often, something weird happens, just like 1 in 1,000 times, 1 in 10,000 times. I find something unusual that I don't want. But I don't want to go back and retrain the whole thing. That's a lot of work, and it risks bad things happening. And so many models now have a feature called unlearning. And unlearning essentially says, I will take whatever the thing is that you don't want there and just remove it. It'll go poof. And it sort of works. The analogy I use is, imagine if you were thinking a bad thought, and you don't want that thought in your head anymore. It's been bothering you for a long time. There's a whole movie about this, by the way, in Long Island. But you literally reach into someone's head, you pull the neurons out that associate with that thought, you just throw them away. It sounds simple enough, but if you know anything about how the brain works, it's not that simple, and other things are going to happen as well. People have brain surgery. Doesn't matter how targeted it is, weird things happen. And so unlearning is very, very hard. If it's a simple, straightforward detail, it might work fine. If the data being unlearned is somewhere that's isolated, this may work. The challenge, though, is it becomes a habit. Like all things in our world of software development become a problem, it becomes a habit. You say, I did this once and it worked. So I'll do it again and again and again and again. But unlearning is like fine-tuning. If you do it a lot, it's going to eventually give you problems. And the reality is the algorithms used for unlearning are complicated, and they're not fully tested yet. On many platforms, they're still kind of a new feature. It's kind of like a beta test. So I urge caution. You can use unlearning, use it for isolated scenarios, don't overuse it. If you find yourself unlearning everything, then you've got a problem. That's a symptom of a problem. You've brought bad data, you didn't train very well, something is wrong, figure it out. It's just a caution here. You know, unlearning is often used to avoid things that are legal issues or bad data or PII, but just be cautious that the more you do it, the weirder things may get, because you're ripping stuff out, and you don't really know what's going on behind the scenes, right? Like, I don't know exactly what it's doing. It's hard to prove it, but it's doing it with my data, so I may not like that. So just a caution on learning. It's a newer feature. It's not very, very well tested in most platforms. It may have bad results. One final note before we kind of wrap up and get some questions in is intelligent capture. The idea here really is that you may want to use the results that AI generates to feed back in and create new data. For example, you ask me a question like, hey, Ed, how can I help you today? And I say, I really want to learn more about this Pokemon. And in addition to giving me information about the Pokemon I want to learn about, yeah, I like Pokemon, it's cool. It says, okay, I'm going to store in my system the fact that Ed likes Pokemon, and then which ones does he like, and things like that. And so you can actually store information from your prompts that people put in, and then use it as part of the data to generate more results in the future. It personalizes things. That's called intelligent capture. There's different ways to do this, different ways to capture information that people provide and reuse it. Be cautious of how you do this, because you're creating new data, and you're creating from unauthoritative sources. I'm an authority on me, but like, I could make stuff up, I can have typos, I can say random things, I could be like late in a Saturday night, I'm really tired, who knows? So be cautious, because when you take new data that people generate from AI and feed it back into the algorithm, you can create feedback loops, you can create more bad data. Just be cautious in how you use that data. And there's value in QAing that new information as well. You mentioned QA a lot. It's a critical skill in life. If you are doing lots of development and not a lot of QA, I wish you good luck. You're going to have a lot of long releases you're not going to like, I can promise. You're not going to enjoy it. I mentioned feedback loops. This is really straightforward. If anywhere in your application there's an arrow that goes backwards and says, take the output of this and put it as input over here, and then feed it back through, just have caution. This is where a lot of bias comes from in our algorithms. This is where a lot of bad results come out due to magnifying something that's already there. You want to have algorithms that are racist or biased or make huge sexist mistakes all the time. This is where they come from. Because, for example, the internet as a data source, is it full of beautiful, unbiased information from lots of level-headed people? Anyone? Oh, yeah. Internet's perfect. Everybody on the internet who posts anything is perfect. It's got to be true. Everyone's level-headed. It makes sense. But what ends up happening, though, is that information gets reused over and over and over. And it's very, very easy for my study of public health or airline prices or whatever to go off the rails, because I simply end up having the same things going back and forth and back and forth and back and forth. The algorithm thinks this is really important, but it's really just one thing I repeated over and over, and it got magnified. So be cautious of anywhere in your application where data goes from one point backwards and fed back in, because it's not necessarily wrong, but you need to be aware of how it gets used and make sure that it's not going to get overused or magnified, or the potential for one thing to become a big thing that isn't. All right, we're near the end here. So the whole conclusion of this whole presentation is that your data is critical. It's the thing that will give life or death to your application if you're working in anything, not just AI. This is really just classic analytic knowledge going back to like the 80s. But we're doing more now than ever, and we're trusting more than ever. In our data, we trust, right? So more than ever, your data quality matters. And if you're not testing it, validating it every step of the way up through the end, QAing it, make sure that everything's perfect, you will end up in a bad place eventually. And so your AI models will behave however they behave. They're trained, they're going to behave. That's what they're trained to do a thing. They're not geniuses. They're not going to do amazing things for you unless you give them really great guardrails and good data. That's simply how it is. So make sure you test your models and ensure that the underlying data for training, for bringing your own data, for whatever you create along the way is valid and correct. And if you see problems, bad data, hallucinations, weird results, whatever, address them as directly as you can. Find the source of the problem and solve the source. Fixing it later down the line may not work very well. So fix it at the source, and your life will be a lot better. It really will be. You'll thank me. You'll thank yourself. It may take longer, but you'll be better off. So I'm going to stop here for a few minutes for questions. We run out of time. We can chat. Chatting's cool. Does anybody have any questions about anything? I went very, very fast. I love going fast. Yes?
I have a comment.
Sure.
Your topic of unlearning, but also your whole thing, reminds me of Eternal Sunshine of the Spotless Mind.
That was the name of the movie. So I mentioned earlier there's a movie about that, and that was the movie. Thank you for remembering the name. It was like half in my head, but my algorithm didn't get it. So, but thank you. I will now try to remember that. That was the movie.
What's the movie?
Eternal spotlight of the sunshine of the, what he said. I don't have a hard drive. Yeah, I go to sleep at night. Weird things happen up here. Yes, next question.
I've heard that the amount of AI-generated images online has become so prevalent that AI image-generating models are starting to use their own output. Have you heard of potential solutions of what we would do about that?
The solution ultimately is guardrail and bring your own data. Bring as much of your own trustworthy data as you can, or if you choose data from an untrustworthy source, give it guardrails. Make sure that the data is created between certain points in time, or that the topics or sources are limited. I know it's a hassle to guardrail things. We want more data, but you're 100% correct. The question was all about what happens when your generative content is flooding your training data and making it make mistakes, and we can't fix that. The answer is that the internet right now is full of AI slop, tons of it. You go to any website that does not have an editor checking everything, like Reddit or Medium or Stack Overflow or whatever, there's garbage everywhere. It might be correct garbage, but it also may not be. I had a presentation about 8 months ago, did a live demo of a brand new version of ChatGPT with a brand new generative AI algorithm in front of it that would generate images based on chat prompts. And I asked it to generate a frog in front of the moon at night. That's simple. It generated a frog in front of 2 moons at night that had 7 fingers in each foot. And I'm like, what is this thing? This is not a frog. I like frogs. That's like an abomination. This wasn't hard. Like, I have a stuffed animal right here. How did you mess this up? And the answer was, I don't know what it did. I have no idea where the data came from. I don't honestly know how it did it. It just did it. And then everybody chuckled, and I gave a frown and said, here's an example of bad data. So you really need guardrails. It's not just having good data. It's about having guardrails, understanding where it comes from. And if you have open areas where more data can be brought in, ensure that that's guardrailed as well, maybe by date, time, et cetera. One more question, at which point we should probably turn it over to the next speaker.
So this is dumb. Check the logs. Like, if anybody making a model, don't they include logs? Don't they include some type of thread that you can go back and see where things are coming from? Or is it just so reckless that it's just like, oh, we don't need logs?
This is a great question. Why don't you check the logs? And the answer is we should. Almost every application logs tons of information about requests, results, time, everything. We log tons of information, but the challenge is we have to develop an application, get new features out by next Friday. Who has time to check the logs? And the answer is you should. The answer is we should all, in any development process we have time to check our work, QA, and validate. And you're 100% correct. And many people don't do it enough because they simply don't have time. The beauty, though, is you can automate it. You can truly automate testing against logs and have a computer check it for anomalies for you. And that's really the key, is have it check it, filter out 95% of the garbage, then the 5% of the interesting stuff comes to you, which you can then filter through very fast.
So then your confidence score, that's an avenue to go back.
Bingo. But you created the filters or whatever, and therefore you understand what's being thrown out and created. Let's turn it over to the next speaker now, because they're going to be talking in 10 minutes, and I hope they plug it in. It works easily. So thank you very much for coming. you. Any more questions, feel free to find me and we'll chat. But I will unplug now, let the next person in and do their thing.